Alright, so what determines if you float or sink? It's all based on density, right? So if you are more dense than liquid water, you're going to sink. If you are less dense, you're going to float, right? Right. A lot of fish have things called a swim bladder, and that helps them to float. So it is basically just this air-filled sac in their body that they use to help raise them or lower them in the water. Scuba divers also have a vest that is filled with air that they can decrease the air in it so that they are at the right density, so they don't have to like swim against either floating up or floating down. They can stay pretty similar. Or sometimes they use weights or whatever. Kelp also has little swim bladders. They're like these little pockets of air that you can find on the leaves that help to keep the leaves up and in the most light and up high. Other algae use stuff like oil. So here you're going to get this little algae here, and these oil droplets allow the algae to float because that oil is lighter than water. Most oils are lighter than water. So if you put oil in water, you can see that it's going to come up. And so this oil helps these algae stay near the surface where they can do photosynthesis because they need light, right? And then we have viscosity. So viscosity is how thick a fluid is. So how hard is it to push against? So if you think of something like motor oil versus water, which one has a higher viscosity? That's going to be the motor oil. It's a lot thicker than water, right? And so even though it is less dense, it has a higher viscosity. It's a lot thicker. Like maple syrup has a really high viscosity. It's really thick stuff. So what do you think is more viscous? Cold water or warm water? It's going to be the cold water. As it increases its density, it also increases its viscosity. And viscosity impedes that movement. It's hard to push through something that is really viscous. But it can also help you move because it gives you something to push against. So air has a viscosity. It is a very, very low viscosity until you get faster and faster. So as you increase speed through the air, you can feel that pressure of the air. So the viscosity feels more. But here, so viscosity allows you to push through it. It can also stop you from falling. So these little filaments reach out and kind of act like a parachute for some microorganisms. And so they can use those and the viscosity of the water to stop them from sinking. Think of kind of like a jellyfish and the parachute it uses. It's using the viscosity of the water to stop it from sinking. Water is also really good at dissolving inorganic molecules. A lot of these molecules are important for life, which is a great thing that life started in water because these molecules were already there. And so all we have to do is bring them in. You may have heard CHNOPS before, back in intro bio, I hope. It's like the 6 major molecules that you have or that are necessary for life. And so you have your carbons, hydrogens, oxygens, nitrogens, phosphorus, and sulfur. Carbons, hydrogen, oxygens, those make up a lot of your macromolecules. So your stuff like carbohydrates, your starches, and then your nitrogens make up a lot of your proteins, your amino acids, phosphorus, and sulfur you find in your nucleic acids. So those are really big. But we also have some other ones like potassium and calcium and manganese and iron that are important. So I think of manganese and iron for your blood and your bone strength. Also with manganese, also with calcium in your bones for strength. Potassium, the sodium potassium pump is a great example. This right here, this is a diatom. It's a type of algae. It also needs other nutrients, not even these ones that we named. They also need silica because they make their shell, their test, out of glass, which is really cool. So, it just depends on the organisms. Some bacteria need this stuff called molybdenum, which is part of an enzyme they use to take nitrogen from the air and fix it into ammonia. So if you hear about nitrogen-fixing bacteria, we're talking about these guys with this molybdenum. And so what makes water really good at dissolving inorganic nutrients is hydrogen bonds. So water's a great solvent. Solvent is the thing that is making the solution, is the base, and then you have your solutes, is the stuff that gets dissolved into it. And hydrogen's really good, or these hydrogen bonds are really good at making water a great solvent, because water is polar. If you look at it, it has a partial negative side here with your oxygen, and then you have these partial positive sides here with these hydrogens, because they don't share the electrons equally. Oxygen kind of hoards the electrons, and so it makes it a little more negative, while the hydrogens don't, and so they're a little more positive. And so you get water breaking up into these really unique shape where you have these, it's basically like a little tetrahedral here, all branched off each other. And so when you get a molecule like salt, here's sodium chloride, into a solution of water, the partial negatives will come and surround the positive ion, the sodium, and then your positives will surround the anion, your chloride, and it separates these two molecules, and so it dissolves the salt by breaking it into its components, and then they form this thing called a hydration sphere, where you basically, whatever molecule you have is going to be surrounded by water. And water has a saturation limit, and it's different for different molecules. So for some molecules it's higher, like carbon dioxide, the saturation for water is basically what we have in the air, while oxygen's a lot lower. If you think about the saturation point of like salt or sugar, like you can build it up, but there's going to come a point where the water just can't hold anymore, and then stuff is going to come out. So as soon as it gets saturated, anything extra is going to lead to sediments, and then you'll start getting stuff dropping out or precipitating, right? If you think about like water and how it's great at eroding, right? It's able to break stuff down, and then it can absorb it to a point, and once it gets more, it just drops it out. And so like sedimentary rock is made from water precipitating out these sediments. Another thing that makes water really good at erosion is that it can change its acidity, and that's where we're going to pick up on the next one.